Hey everyone, welcome to my second compiler design video. In this lesson, we're going to discuss finite automata, and in particular, deterministic finite automata, or DFAs. Now, a finite automaton is a machine that has a number of states it can be in, and it can take inputs while it's in a state to transition to another state. What exactly does this mean? Well, to go into a bit more detail, a finite automaton is a 5-tuple, which you can think of as meaning it has 5 components. Q, which is the set of states it can be in. Sigma, which is the set of inputs it can take. Q0, which is the starting state, which is singular, there's only one starting state. Qf, which is the set of final states, so there can be multiple final states. And delta, the transition function. The transition function takes a state and an input and it outputs another state. So a transition from one state to another occurs when an input is received. Now DFAs, deterministic finite automata, are finite automata where there is only one transition per input. So for every particular input, while you're at a state, only one transition can be made for that input. Now we're going to see what that means in a minute. So this is a deterministic finite automaton. So we've got a number of states, Q0, Q1, Q2, Q3, and Qf. And we can see that this deterministic finite automata takes A's and B's as inputs. Now, if we were to be at state Q0, for example, let's say we're just starting an input, and we were to take an A, we would transition to state Q1. And it's deterministic because at no point does a particular input at any one state produce two transitions. In every state, an input of A leads to one other state, and an input of B leads to one other state, or potentially the same state. But there is only one transition per input. Now, if we were to try and input AAAB into this deterministic finite automata, we'd be able to tell whether AAAB is part of the language that this deterministic finite automata represents. Now, if we put in an A, we get from Q0 to Q1. Another A puts us in Q2. Another A puts us in Qf, which is the finishing state, the final state. And the B puts us in Qf once again. So AAAB is a part of this language. What about BBAA? Well, the first B puts us in Q2, the second B puts us in Q3, and the two A's just put us in Q3 again. Now, there's no way of getting out of Q3. There's no transition from Q3 to any other state. So this means it's a dead state. So it's like a dead end. And what that means is BBAA is not a part of this language. So just roughly looking at this, we can tell that the language this DFA represents is any number of A's followed by any number of B's, or an A followed by any number of B's, followed by any number of A's, followed by any number of B's, and then any number of B's at the end can again be followed by A's, or it can be a mix of A's and B's. Pretty much the only thing it won't take is two B's followed by anything else. And that's only at the start. Now we'll go into more detail on exactly what language this represents in our next video. But for now, I just want you to get the idea of what a DFA is. And as you will have realized, DFAs are used to represent languages. So they're used to sort what strings are a part of a language and what strings aren't a part of a language. And this has many uses that we're going to get onto in later videos. So that'll be all for now. Thank you very much for watching, and I hope you tune in next time. See you later.